In this lecture, we shall learn about gravitational field and do a couple of problems on that. According to the gravitational theory of Newton, two bodies which are not in physical contact with each other, they can exert gravitational force on each other. Because of the grand success of Newtonian theory, there was no immediate challenge to the Newtonian principle of action at a distance, which stated that the effect of a force, be it gravitational, electrical or magnetic, can reach from one body to another through empty space. But it was Michael Faraday, much later, that is in the middle of 19th century, the Faraday also was from UK and the time was middle of 19th century. He proposed his field theory, which stated that a body creates a gravitational field around it by virtue of its mass. Unlike a true vacuum, a gravitational field is a physical reality which occupies space and contains energy. For example, if you consider this body here, because of its mass, it creates an environment called gravitational field around it. So when you place another body nearby in the vicinity, the space between these two bodies is not empty, it's not true vacuum. Actually, the second body is placed in the gravitational field of the first body and it responds by experiencing a gravitational force exerted by the other body, that is the first body. For example, if we take a point, say P, and suppose a particle of mass m is placed in this position, and the gravitational force experienced by this particle of mass m placed at this point P, let it be Fg, a vector quantity. By definition, gravitational field at the same point P is defined to be the gravitational force experienced by the particle divided by the mass of the particle. That is my first important equation, and it gives mathematically the definition of gravitational field. Once again, this is the gravitational force acting on a particle at a given point divided by the mass of the particle that gives field at that point. Now, since Fg is a vector quantity of force and mass is a scalar quantity, gravitational field is also a vector having the same direction as the gravitational force. Let me also put the statement, that equation number 1, in words. We could say that the gravitational field at a point in space is the gravitational force experienced by a unit mass placed at that point. Force by mass is, of course, force experienced by unit mass placed at a given point. We can make use of the definition here to also find out the dimensional formula and units of gravitational field. Obviously, the dimensional formula of gravitational field is the dimension of force by the dimension of mass. Now, the dimensional formula of force is m into L into t to the power minus 2. Dimension of mass is simply m. M cancels out, and you see that gravitational field had a dimensional formula of L into t to the power minus 2. So, this is the same dimensions as our acceleration. You must note it. The unit of gravitational field in SI will be force by mass, that is Newton per kg, which you can check yourself, is equivalent to meter per second square, the same unit as that of acceleration. Now, once we define gravitational field at a given point by equation number 1 and the statement below, let us apply it to find out gravitational field of a particle and of the earth at a given point. First of all, we shall consider a particle here. Suppose the mass of the particle is taken to be m1, and you consider a point P at a distance of r from this particle. So I show the distance here. The distance between the particle and the point in question is taken to be r. We place another particle of mass m2 at the position P, and you already have learnt in our classes of law of gravitation that the particle of mass m1 exerts a force, gravitational force, an attractive force on the particle of mass m2 towards itself, and you can express this gravitational force on the particle of mass m2 at point P to be, well, this force is equal to magnitude first, gravitational constant capital G into the product of the masses of the two particles m1 into m2 divided by the square of their separation. This is the magnitude part, and into I write minus r cap. It shows that the direction of the force is towards the very source of the force. Since m1 is exerting this force of Fg on m2, the direction of the force is...
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.